Recording. Okay, we're recording, we're on.
All right.
And we'll be on Facebook in a minute, so start up if you want to.
All right, okay. All right, I would like to call to order the Friday, October 2nd, Zoom meeting of the North Shore Amateur Astronomy Club, whose mission is to promote the science and hobby of amateur astronomy in the Merrimack Valley and beyond, attempting to provide our membership with the highest quality experience in this price range. Okay, so I will call the meeting to order at 7:39 p.m. What we are going to do is we're going to go through our regular business meeting. I do have a lot of new business. Okay, but first of all, I would like to acknowledge the presence of any visitors who may be among us tonight. So if you're a visitor, just give us a brief, or however long you want, just hello and self-introduction, and we will welcome you to our midst.
I'm Joe Serecchia. I'm Michael's father. Can you hear me okay?
Yes.
Yeah, thank you.
I'm Michael's father, and right now I am in Naples, Florida.
Wow.
So Michael and I have been tinkering around with that telescope, and Michael seems to be grasping it and getting some good images out of it. And we're just here to learn more about observing objects in the sky and to see what we can do to appreciate it.
All right. It is our belief that you have come to the right place.
Yeah, great.
Okay. Are there any other visitors?
Not with their microphones on, I don't think.
Okay. All right. Seeing as how we have run the gamut of new visitors, we will begin with our department reports. After, of course, checking to make sure that everyone has read the minutes of the last meeting.
The last two meetings have been posted.
Okay.
August and September.
There we go. All right. Well, that settles that then. So now moving along to our department meetings.
You have to approve them.
Say again?
You have to approve the minutes.
I will approve the minutes.
Okay. Good.
All right. Does anyone object? No. Good. All right. Good. Now, moving right along to our department meetings. Do we have a report from either Salem State or Merrimack observatories?
Salem State is status quo, no change. We still haven't opened. We still don't have the go-ahead at this point in time. So.
Okay. All right. Thank you for that report, Dennis. Do we have any information at all about Merrimack?
Talk to me in 2021 though. They did get a camera to start
Okay.
playing around with some live streaming, so we might be helping with that. But
Okay.
that's it.
Okay. For the benefit of our visitors, we run the observatory at Merrimack College, which is very large, 25-inch telescope that sits in the dome that you can see from 114 on the roof of the science building. We also run the observatory at Salem State College, which is an observatory that has, how big a Schmidt-Cassegrain is it again, Dennis?
Oh,
12-inch Schmidt-Cassegrain telescope. And is it a Celestron or a Meade?
me.
Okay, so it's not a Celestron like our visitors. have, but-
100 ACF.
All right, that's advanced coma free.
Yep.
All right, thank you.
You don't believe
Okay, so is Ron on with the treasurer's report?
Don't see Ron.
All right, so then we will accept the treasurer's report as unchanged then, because I think that we don't have any report if applicable. Okay, so star parties is still a no-go for everything, right?
Yep.
Okay, so that does it, star parties. Okay, so now I guess we will move right along to new business. And I will start out the new business by giving everyone the rundown of the speakers who we have managed to book through the month of March. So we have I think some guys who will give us some pretty good presentations tonight. Of course, we have our good friend Phil Orbanes, who is going to be presenting Einstein's block universe. And we're all big fans of Einstein, and I'm sure that will be wonderful. And very much looking forward to that right after this business meeting. On November the 6th, we have booked our old friend Ryan Goodson, who, for those of you who probably remember, he is the one that drove out to us with a big trailer with a 27-inch f3.5 Dob a few years ago, for which we had an observing session back when we were at Vesey Park. And we were lucky enough to have a night of tremendous seeing, and we got some incredible views, the best one being M13, the Hercules cluster. So I think a number of you were there. And so Ryan is going to be giving us a Dobsonian update, and in particular, he wants to share with us some new Dobsonian construction techniques and also observing with ridiculously large amateur telescopes, during the COVID era. So that should be, quite interesting, and it will be very, very nice to see him again.
Brian, is his name Ryan or Brian?
Ryan, R-Y-A-N. It's
Okay.
me without the B. Yeah, Goodson. Yeah.
Yep, got that.
Okay, on December 4th, we are going to be hearing from an astrophysicist at Montana State University, Eric Davidson, who is a PhD candidate out there. If his name is familiar to you, it's because he was on the team that was able to successfully image the black hole. So he was on that team. His current research interests and what he's probably going to wind up doing his doctoral presentation on are quark stars and strange stars, which is sort of like an intermediate in between neutron stars and black holes. But the topic will be to be announced, but it will be dealing with some of his current research interests. They have a very active astronomy program out there at Montana State and University, and that should be pretty good. Now, we have to talk about January for a second, because the first Friday in January falls on January 1st, which is New Year's Day, and I don't think that a whole lot of people would want to have an astronomy club meeting on January 1st, and we can't have it on January 8th because we don't want to conflict with GAC, because so many of us have dual membership with GAC, which is, of course, the Gloucester Area Astronomy Club. But I have booked for January somebody who is no stranger to us, because he is a contributing editor to Astronomy Magazine and also contributes a lot on the Cloudy Nights Forum and at NEAF. Phil Harrington, who is the author of the two books, Starware, and he says that he would love to give us a talk in January, as long as it's just not on January 1st. So if we can decide, what night in January we want to have a meeting that's not on January 1st, we have Phil Harrington. And Phil is interested in giving one of three talks that he is currently, working on. One of them is called Two Eyes Are Better Than One, which is a presentation on everything to do with binocular astronomy, choosing them, buying them, getting the most out of them, things like that. Then he has another presentation, which is called Nights of Future Past, which is a retrospective of amateur astronomy in the 20th century. And then a third talk, which he is interested in presenting, is called The Next Great American Eclipse, dealing with what to expect and how to prepare for the upcoming great eclipse of 2024. So what Phil has asked me to do is to see if we can come up with a night for our January meeting that's not January 1st. And then he has asked me to sort of poll the membership and find out which of those 3 talks we would be most interested in him giving. I'm just asking everyone, what can we do to have a meeting that's not January 1st?
Well, does it have to be on a Friday?
I don't believe it does have to be
So-
on a Friday, especially because this is kind of extenuating circumstances, because we don't want to have it the second Friday because we don't want to, you know, conflict with GAC.
Well,
So,
what's wrong with Thursday and start it a little
Right.
later, like 8 o'clock?
well, we don't want to do the Thursday that's right before that because that's New Year's Eve, which would be, you know,
Well,
even,
No,
What about January 2nd?
which is a Saturday night.
Yeah,
I can ask him. Yeah, I can ask him. I think he'd probably go for that. Now, assuming that Phil Harrington is okay with Saturday night, January 2nd, and the rest of you would be okay with doing it on Saturday night, which of those 3 talks, just polling you guys, would sound the most interesting to you?
Brian, can you just repeat the titles of those 3?
Yeah, one of them is 2 Eyes Are Better Than One with Binoculars. The second one is Night of Future Past, which is a retrospective of amateur astronomy in the 20th century, which sounded to me pretty interesting because he'll go into, you know, the advent of the apochromatic refractors, you know, the Dobsonian evolution, you know, all kinds of stuff. And then the third one is the one on the Great American Eclipse of 2024.
I vote for the middle one.
I do too.
Yeah,
All right, so we'll go with Nights of the Future Past, retrospective of amateur astronomy in the 20th century.
Yeah, that sounds cool.
Yeah, I'm gonna, all right, so I will ask Phil if January 2nd would be okay. I'm thinking it probably would be. And so let's go with that. So we're gonna try to get Phil Harrington for January 2nd, okay? Now, on February 5th, which is, you know, our regular, you know, February meeting, Alex McConaughey, who has done a lot of presentations at NEAF and also for astronomy clubs and star parties all over the country, has agreed to give his presentation on sort of like the 5 greatest astrophotos of all time. And I tried to guess, you know, which would be my 5. And he said, well, you may have some of them right and you may not. He's kind of a, you know, he's kind of like that. But so that would be like the 5 most dangerous astrophotos of all time. So like my guess would have been that one of them would have been the photograph of M31 that Edwin Hubble took, where he saw the Cepheid variable and proved that, you know, that M31 Andromeda was outside of the Milky Way. And another one, of course, I thought would have been Eddington's, you know, eclipse photograph of the stars around the sun, which proved that Einstein was right and that Newton was not so right as far as, you know, gravity is concerned. But, you know, then there are 3 more, which, you know, who knows? But this should be a really good talk. And that one is going to be on February 5th. Okay. Now, on March 5th, some of you might be familiar with this book from the Patrick Moore Practical Astronomy series. It's called Choosing and Using Astronomical Eyepieces by Bill William Paolini, who has agreed to give us an update because he's compiling this kind of information for the new edition of this book. It's going to be an update on eyepieces and filters. He recently did a filter, you know, update that was on cloudynights.com. He also, you know, writes a lot for Astronomy and Sky and Telescope magazine. And I think except for probably Al Nagler, he's probably like the most knowledgeable guy in eyepieces that, I've ever met, with myself being probably a close third, but he is, pretty damn good. And, I've been, friends with him on, cloudy nights for a while, because we always, talk eyepieces and on the eyepiece forum. And he said that he would be more than happy to give us a talk. The other thing is that he has, normal size, kind of mainstream telescopes that he uses, his eyepiece in. Like, he's got a 10-inch, mainstream, Dobsonian reflector. He's got a 4-inch, apochromatic refractor. So, he has, the typical, kind of telescopes that we use. And he's, from the research that he did on his book, he's tried just about every eyepiece and every filter with them. And, he brings us a lot of insight. So that's the scheduled speakers through March. And Phil Harrington said that if we couldn't get anything figured out, that would work for January, then he could give his talk in April. And then in January, we could do, like, I don't know, a gadget night, or, and if anybody, wants to give a talk, on something they're interested in, even if it's not like a full, 45-minute talk, if we had two people who wanted to do, like, a 20-minute presentation on something they were interested in, we could do that too. There's no reason why, we couldn't, do something like that. We also had a gadget night, at one point that was, I thought it was, pretty successful to, to see what everybody, had in their, equipment case, and, to be able to see them, in real life, and, and do it. And then, maybe even hopefully at some point in time, we'll actually be able to have, my favorite kind of, entertainment activity, which is actually going out in the field and observing and looking at stuff. But I think we've got some pretty good guys, lined up. And I think that these, should be some, pretty fun talks. And if anybody, wants to volunteer for a future talk, or, wants to, help with recruiting talks, just let me know. And that would be, very much appreciated too. Basically what I did is I went down through my buddy list on cloudynights.com, and I found that a lot of, noteworthy people were, interested in, giving talks. I'm also going to try to check out with some of the other local universities, because, some of the graduate students and, PhD candidates, they're interested in giving talks, because it's good practice for them for, when they have to, do their grant presentations and stuff like that. So, that could work out too. So what I will do is, at some point in the near future, I'll give, the contact information to, to Brewster and to Mike, so that we can send the guys to the links, to get on, and we should be good. Does anybody have any questions, comments, or anything else?
Can you type up a quick list and send it to me?
Yeah, sure. I'd be happy
Put it
to.
in the minutes?
Yeah.
Okay.
Yeah. Okay, that's no problem. I'll do that within the next 24 hours. All
I
right.
have one small point for when you contact Guy about January 2nd.
Yeah.
Just to shorten the conversation, if he can't do that, maybe we could offer him the 9th and get it done in one phone call, rather than have to call him back after you consult us.
Okay. So either the Saturday the 2nd or Saturday the 9th.
Right.
Great. And then, like, if he's got a bar mitzvah or something on January 2nd, he could still do January 9th. Okay, that's a good idea. Thank you. That's a good idea. Any other comments, questions, suggestions, or anything like that? Okay. And so the only people who I was unsuccessful at trying to get to give a talk is I actually called Al and David Nagler to see if they would give a talk, but they're so crazy over there with the COVID going on right now that they said that they'd be in touch with us later in the year. So later in the year, we might have, either Uncle Al or, Cousin David joining us, which would be interesting. Okay, so that's all that I had for new business. Is there any other new business?
I don't know about new business, but just Mike and I were talking. For Brewster, do you know how to get the Salem State and the Merrimack blogs back online?
Take a look at the page. They shut them down because there weren't any new posts. That's what the notice says, and there's nothing to click on that I can see.
Oh,
Go to the page. It's weird.
I didn't even notice that.
I didn't know about it until Dennis told me about it.
Yeah, I think they're set to only show the most recent 3 months of content, and if there's been,
There'll be a setting in there somewhere.
That's
Yeah.
what I thought. Yeah.
okay, I didn't even realize they weren't there because I haven't had any reason to go try to
Yeah.
look at them. So,
I tried to update just to let people know why
right,
they still weren't open, and I couldn't get anywhere.
okay, I'll take a look later and let you know. And we should probably just post once a month. Oh, still
Yeah,
not open.
obviously.
Okay, thanks.
Okay, thanks.
All right, any old business?
I have one matter of old business, which I'd like to get at. I renew my call, and this is the last time I'll bring it up if the club doesn't want to do it. But I renew my call for a board position to take care of meeting entertainment. Brian's done a terrific job booking it till March, better than I could have done. People I never would have known how to reach. But I think that one of the things that NSAAC has been tripping over in the last 20 years is this hero thing. And I came in and did the hero thing and got us the new meeting place. And now Brian's doing the hero thing. And this is great. Everybody cares about the club, but the club should be able to run on its own without anybody having to do heroic things. That's my only point. And I worry about the club sliding back into, well, gee, we don't have anybody booked for this month or the next month or the next month because Mike Deneen isn't around and Brian Stone isn't around.
It was kind of a little bit easier, believe it or not, with the COVID, because I was able to hit people from all over the country, and because they didn't actually have to come here physically, and they could do it from home, it was a lot easier than, trying to, get people to actually come out to, the clubhouse and give a talk.
Should do all our meetings virtually.
Well, we probably will right through January, most likely.
Well, if we ever do, get back to the clubhouse, which I'm sure we all hope we do, there's no reason why, we can't continue to ask people all over the country to give meetings, because we could just have a virtual presenter, while we're at the clubhouse. And then after the presentation, then we can do what we should be doing, which is, to get out in the field with our telescopes and actually start looking at stuff and taking pictures of stuff.
So to my point, I don't know how you want to handle it, Brian, if you want to have a vote or what you want to do, but I really urge the club to do this and take care of presentations once and for all, have it be somebody's job.
Yeah.
If it's going to be a board position, it's probably got to, probably got to do the bylaws to get
That's
it.
easy.
I know, yeah, but
let's think, at least now we're not in a crunch and we can think about that. And, those, maybe, if somebody's willing to, where like, you could even have like, if 1, 2, or even 3 people, were willing to, do it. I mean, we could have like an entertainment committee, we don't have to have, it fall on, just one person. I mean,
well, but that's the problem with the committee is the guy who's in charge of the committee usually does all the work. And
yeah,
then
that's
it'll
true.
fall
too.
back on one person again.
All right.
That's
Well,
my feeling, probably.
All right. So what we'll do is we'll put in the minutes that if anybody is interested in, volunteering to take this on, beyond, March into the next fiscal year, just let us know. And we should also, tell that person that, we'll give them all the support that, we have.
And
You
they
know-
could start with the elections, you know, we could just,
Yeah.
when we elect everybody else, we can elect them,
Yeah,
such as our elections are.
okay. All right, so any other business to come before our honorable organization before we,
I
Sure.
do.
all right, yeah,
I won't bore the club with it, but I'm still having trouble with, on the website, trying to get photographs on. When he gives me a observing thing that has more than 3 images in it, I can do 3 images, but he gives me 4 images. I start to put the 4th image in, and I get an image from I don't know where in the hell. It's not what it says I'm putting in, and I can get rid of it, but then I don't have an image to put in. As soon as I go back to try to put a 4th image in, it just puts this weird image in of something else that's been on the observing sites before, but it's nothing I have. And I
Is
don't
it
know
always the
if I'm-
same image, John?
Huh?
The image that's not supposed to be there, is it always the same one?
No, it depends on which one I'm doing, where I'm at. And he gave me one, the last one he gave me, I think it was the Veil Nebula. He gave me 6 images, you know, he gave me some of his drawings and something else, and he gave me a picture of the whole veil, and then he broke it up into 6 pieces. And I could only get 3 pieces in before the thing went to hell in a basket. So I just didn't put the other pieces in and left it that way. And I went back and looked at one that I had done. I forget, it was M8, and there was a veil picture stuck in it, and I didn't even put it in there. I have no idea where it came from. So something's going on with this when you add a picture. If he gives me three items, I'm fine, or maybe even 4 sometimes. But if he gives me more than 4, it depends on what it is. It just puts these strange pictures in that I don't know where they're coming from. They're pictures that have been on the website before in some other observing thing, but they're not. And I even went in and deleted them, everything I had to do with that picture, and it still came up when I went to not paste, but go get it from the images. So I don't know what's going on.
John, just email me next time you need to do something. I'll try it out. So,
Okay.
oh, I think I figured out 2 more of the astrophotos that are going to be in the 5 greatest astrophotos of all time. I think one of them is going to be the black hole image, and I think the other one's going to be the Hubble Ultra Deep Field. So I guess we'll see if I'm right.
They may sneak in that Hubble horse head.
Yeah,
All right.
classic.
Another one would be the Einstein's cross with the gravitational lensing. That was very important too. But I guess we'll see. I mean, that's the fun of the presentation, is he's not going to tell us, you know, in advance which, you know, 5 astrophotos or astro images he wants to talk about. And also he says that they're images, not necessarily photographs. So that kind of makes it interesting too. All right. Any other business?
Would you like us to have any motions?
Motion
yeah.
adjourned.
Oh, yeah. Okay. Do I have a motion to adjourn and turn the meeting over to Phil?
So moved.
All right.
Second.
All right. Motion carried. And all right. So Phil Orbanes, our old friend, is going to give us a presentation on Einstein's block universe. And I will turn the program over to Phil now, who can you know, elaborate on that. And I'm sure that this is going to be a wonderful presentation. Phil, are you still with us?
Yep, thank you, Brian.
All right, great.
Okay, so I'm going to press share screen. Michael?
Yeah.
Okay, so before we begin, let me just give you a very brief introduction so you'll know something about the scope of tonight's presentation. Before he died, Albert Einstein rejected the distinction between past, present, and future in a letter that he sent to the family of a deceased friend. In one particular passage, and you're going to see the passage later in my presentation, Einstein makes reference to what we know now as the block universe conception of space-time, although it came not from him, but from the works of others, principally Hermann Minkowski, who was one of his teachers. But it is the framework in which his own theories of special and general relativity are most naturally expressed. The block universe view of physical reality contains time, but in a way remarkably different than our usual conception. It presents a four-dimensional view in which all events across time and space are on equal footing, with no sense in which present events are judged more real or actual than past or future events. Well, I distinctly remember encountering this theory several years ago when I, at the time, just happened to be producing as a sideline the music for a band in Amesbury, and I was inspired to write a song whose lyrics are based on the mind-numbing implications of the block universe theory. Well, just to clarify, I had been writing songs since I was young, so the tune came easily to me. It's not something that I did one and done. And after I finished the music to this song called Dream Inside a Dream, the vocalists in the band helped me to record it. This summer, I turned Dream Inside a Dream into a music video to serve as the introduction to tonight's presentation, which Michael originally encouraged me to have ready for the Gloucester Club's November meeting. But with a little additional inspiration from Michael, I finished it early, and so I am premiering it for you here tonight. So if all goes well, we're going to start with a music video. Michael has been kind enough to coach me prior to this meeting in how to do this. So let's see if I can get this going. And I'm hoping that I'll get the volume level just about right to begin with. So, whoops, come back here. All right, here we go.
I'm beginning to think beginners to end, and the top's tail end. It's here and then it's gone before I intend. We fly a million miles a day round the grain on the beach in the dust called Milky Way. Are we a dream inside a dream? The wise men tell me it's not what it seems, just a mystery. I thought that I knew what I know, so there you go, now it's history. Stars span the diamond-studded sky, all can fit and submit inside a needle's eye. Are we a dream inside a dream? And I reach for your hand to assure that I stand on the firm ground of truth and sanity. But I wait to your call in a dream where I fall so absurdly. So I'm filling my head so sure that I stand on the firm ground of truth and sanity. But I wake to your call in a dream where I fall so absurdly just to wake, dream again. And now that I know begins at the end, so here we go once more again. To the top 'cause it rocks and I'm over my shock. And we fly a million miles a day round a grain on the beach in the dust called Milky Way. Are we a dream inside a dream?
Okay. Thank you, thank you.
Very Beatles-like.
Oh.
I definitely hear a Beatles influence there.
Well, yeah, I had a lot of fun with the strings in particular and the cello. So now, having given you a something to think about, I'm now going to give you a more thorough presentation of the rather simple idea behind the black universe. It's not a very complicated theory. Its implications are what is incredibly, thought-provoking, if you will. So again, we're going to see, I don't need to share the computer sound on this one, so I'll take that off. Okay, time and, can everybody hear me okay?
Yep.
All right, great. Time and the black universe. So some interpretations of Einstein's theory of relativity suggest the universe where past, now, and the future exist simultaneously. And Einstein himself was very sympathetic to this notion. As a matter of fact, when his friend Michel Besso died in 1955, he wrote the family, "Now that Michael has departed from this strange world a little ahead of me, this means nothing. People like us who believe in physics know that the distinction between past, present, and future is a stubbornly persistent illusion." So the black universe contains everything that has ever happened, ever will happen, at any time and at any place. I'll get back to analyzing in a second. So the block actually has 4 dimensions, 3 of space and 1 of time. So it's all of space-time. So I'm going to go back just for a second. And to make this feasible, to visualize, given our human limitations, the 3 dimensions of space are compressed to 2 dimensions in this diagram. Time is the horizontal axis moving across in the 3rd dimension. Whatever is the current moment in the black universe separates past from future, but it's an illusion because you can never grab hold of it, you can never stop it, it is constantly moving, and in effect, it doesn't exist. So to visualize the 3 dimensions, as I say, they're compressed in the 2, and you're traveling along this great axis of time from the beginning, which is the Big Bang, to the end of time, which in tonight's presentation, we're going to use the big empty theory as to when time actually concludes. Well, many great minds have pondered the nature of time. For example, historian David McCullough, and I chose him simply because he's not a physicist, but he's reflected on it here in a way that's very relevant. He said that Adams, Jefferson, and George Washington didn't walk around saying, "Isn't it fascinating to live in the past?" It was the present. It was their present, not our present, their present. And we have to understand that. So let's talk about space as opposed to time, just to have a counterpoint here. You are where you are while participating in this meeting, but your here is different than the here of the club member you see above or below you or to your left or right. And it's also different than mine. Well, in the Block universe, talking about present or now works just like talk of here. It's all very relative. As a matter of fact, I was just reading a passage in a book over the weekend that pointed out that there is no universal now throughout the universe because everything is separated by distance. And we know that it takes time to move from one point to another. And I figured that about the only component of the universe that doesn't have this problem is a photon, because a photon believes that it arrives the moment it left, which, by the way, is one of the references I make in the song Dream Inside a Dream. The Block universe has many supporters. One of them is Christy Miller at the University of Sydney's Center of Time. I found it pretty fascinating that a university would actually have a full department devoted to this topic. And she's quoted as saying, "In the Block universe, there is no present. All moments that exist are just relative to each other within the 3 spatial dimensions and 1 time dimension. Your sense of the present is just reflecting where in the Block universe you are at that instance." It is surmised that once we know how to construct a wormhole, we will be able to travel back to a frame in the past. And you may remember from the video that you can visualize the Block universe as a series of frames, as in a movie, that run in sequence, runs in sequence from the very beginning to the very end. And there is strong indications that once we figure this out, we'll be able to jump to a frame other than the one we're in right now. And I'm going to talk about those implications in a little while. Of course, it has its detractors. One of them is physicist Leo Smolin, who says the more traditional view, the future is not now real. There can be no definite facts of the matter about the future. What is real is just the process by which future events are generated out of present events. And as I say, this is a more traditional view, and it's the one that, instinctively, I think we all would sympathize with. But there's a lot of professors like David Deutsch and Julian Balfour and Hugh Price that dispute him. They feel the Block universe theory reconciles the cosmological nature of time with daily experience, and therefore it solves many time travel paradoxes. And I could have put several of them up here, but I think this is, being the most classic, this is the one that I thought was most appropriate. So let's say I'm going to make this into your present tense. Here's your grandfather, and he and your grandmother give birth to you. So you, the future time traveler, are born right here. As you get older, you create a time machine. And then you decide, I want to go back in the past, and I want to meet with my grandfather before he meets my grandmother, and I want to kill him. And so if you do that, your father is not born. You, the time traveler, is not born. There is no time machine. So who was the person that killed the time traveler's grandparent because time traveler has not been born? And you can see this paradox is really unsolvable, and other than the Block universe theory. And in this theory, this and just about every other time travel paradox cannot occur, as we'll see. Let's just talk about time in general. No one knows how time flows, if at all. We know time exists. We measure things from intervals measured in seconds, hours, days, etc. but we don't really know how this flow exists, if at all. We do know there's an arrow of time that points from the past to the future, and that's forced because of the second law of thermodynamics, total entropy. Therefore, since we can move from point to point in space, and time is an axis in the block universe, can we move along that axis? Well, theoretically, the answer is yes. We just don't know how to do it yet. You know, in much the same way, I would imagine that those who were relying on wind power to sail the Atlantic could never imagine, you know, flying a rocket to the moon. But since the frames in the past are fixed, we cannot alter them. And by the way, that also means that if we do go back, it would have to be essential to make that frame whole. So we don't have the opportunity to go back and kill our grandfathers. And this solves the paradoxes, as we just noted. So if we think of each moment as time in a frame of a movie, and this frame that you see right here, you will be seeing a lot more of in a moment. Just think of them all existing concurrently. Every slice is just as real as any other. There's no present. This does take getting used to, as we noted in the video. But the question then is just, how big is the block universe? How long is this axis of time? And I thought this was a very interesting realization. If you equate the frames of time in the block universe to a movie, it has just begun. If the entire span of the universe up until this point were 100 years as opposed to 13.8 billion, not even one day would have transpired since the Big Bang out of that 100 years. So let's take a journey from one side of the block universe to the other, from the Big Bang to the Big Empty. We know what the theory is. We know that it's going to project itself for a long time in the future. That what I'd like to leave you with tonight really is, where are we going? Where does it end up? So our journey will take place during a second music video that's named after this. And this one is a collaboration between one of the singers who sang in the first song, Bob Murray, and myself. And in this particular music video, we're going to highlight several of the frames of key moments and eras on the timeline in the block universe. And as I mentioned, each of the frames that you see are going to be represented by this border, and in the lower left-hand corner is going to be a diagram of the block universe, and you'll see how now progressively moves toward the from left to right as the events that unfold become more and more into the future. And I have a couple of cautions about what the future holds. First, it seems that the more we learn, the more we realize we need to learn. For example, Einstein is quoted as saying, "I never made one of my discoveries through the process of rational thinking." And Buckminster Fuller is quoted as saying, "The more we learn, the more we realize how little we know." Well, the reason why that's important is we have a grasp that certain key events are going to happen in the future of the block universe, but they depend on assumptions. And the assumptions are all reasonable today, given the knowledge that we have. And I think that all of you would concur that they make sense. We just don't know what the future holds in the event that the universe wants to play games with us. So for example, we need these three assumptions. We need to assume that the repulsive nature of dark energy is a constant, that at some time in the future it doesn't decide to turn around and become attractive. We also need to assume that protons do not decay. And finally, that the value of the Higgs field doesn't change. Well, since the Higgs field gives all of matter its mass, if even a small part of the universe, the Higgs field, changed its value, all of a sudden it would devour the entire universe like a cancer. So just to have some consistency with common sense at the moment, we're going to make these three assumptions. So the journey will now begin. Buckle up. And again, I'm going to have to share something here. So we're going to go down here. All right. All right. Okay, here we go. A journey through time.
Stars explode into dust. Eons pass without rush. Clouds emerge, red hot gas. Starry genes, we come to pass. This cosmic game filled with twists. Give me peace after this. Sun comes up, sun goes down. 365 spins around. Clocks will tick 5 billion years till the day of solar fear. Bless the time we share the trip. Give me peace after this. Sun goes down, moon appears. Nights of dreams, nights of fears. Why the fight just to exist? Why such doubt? Why not bliss? When the pulse should lead my wrist. Give me peace after this.
Okay. Thank you. Thank you.
Wow, what a buzzkill.
Wow.
Yeah.
Great production values there, Phil.
Thank you very much, Michael. And I'm going to leave you with a joke. So now that you know the nature of the black universe theory, if I just, you can see this, right?
Yeah.
Okay,
I can see your face.
You can see my face. You can't see the joke. I have to press.
You have to share the screen.
Okay, I'm sharing screen. And then I'm sharing. Okay, here. Can you see it now?
Yes.
Yeah.
That's pretty good.
Yeah.
Yeah. Okay. Thank you very much. Now I just got to get myself back on here.
Stop sharing, top of the screen.
There you go. Thank you, Michael. All right. Anybody have any questions, or even more significantly, what I would like to encourage is, what do you think of this? Does this?
Bill,
Yeah.
I have one comment.
Yeah.
In the two videos,
Yeah.
at the top you have a bunch of stuff going across the top, and at the bottom you have the lyrics to your song.
Yeah.
It's very hard to read them all.
I know.
Should you leave it up longer? You know.
Well, see, the problem is, John, the song has a pace to it. I would have loved to have left them up longer. So the only way really to absorb it is you have to see it a second or third time, probably.
Maybe what you should tell people is not to read the song lyrics. Read the stuff at the top and listen to the song.
Yeah, listen, great idea. I think I'll do that for the GAC meeting. Thanks. Let me make a note about that. That's very good.
Other than that, I really enjoyed it. I got most of it, but a couple places I was too slow to get it all, and I don't.
Yeah.
And I think you should get it all because there's two different things going on.
Yeah, great suggestion. Thank you, John.
You're welcome.
Yeah.
Are the conditions in the big empty similar to the conditions of our own universe before the Big Bang?
Well, if we knew what the conditions were before the Big Bang, and if we assumed that there was nothing, then the answer would be a positive.
Because
yes.
then there could just be another Big Bang and start a whole other universe again, and it could be like a cycle.
Right. And of course, there is a lot of theories about renewal where we start and we end and we rejuvenate, with another Big Bang. One of the things that I read during the research for this is that, and I mentioned it in one of the slides, but the physics at the singularity of a black hole don't work. Therefore, a lot of speculation is the way to solve the problem is for the black hole to spew out a Big Bang. That solves the problem if, in fact, you cannot have a defined singularity. So maybe our universe is the product of a Big Bang from a black hole somewhere else.
That's kind of what I was getting at.
Yeah.
And that also solves the grandfather paradox, because when you kill your own grandfather, you're creating an alternate timeline in an entirely new alternate universe.
Precisely.
That's parallel to ours.
Right. And you may have mentioned, or may have noted, Brian, that toward the end of Dream Inside a Dream, I mentioned that true time travel requires the existence of a multiverse, because then you kill your grandfather, you're actually in a parallel universe.
Exactly.
Yeah.
Exactly.
And as mind-boggling as that is, you can't really rule that out.
Well, not only can you not rule it out, I think that's the kind of the way it has to be.
Yeah. The other, from my own point of view, one of the things that I've always wrestled with, my entire life and interest in astronomy and the cosmos, is just the enormity of the amount of matter and energy in this universe that we can see, and that apparently is only a fraction of the total universe. The great amount of the universe probably is beyond our sight because of inflation. And it just seems to me that it's very difficult to comprehend why all of this has to exist if in fact it can be paralleled time and again, it does stretch your brain cells.
I really enjoy walking up to the limits of my understanding and poking it with a stick, saying, "Yep, that's there." It gives me great solace.
Well, you know, I agree with you. And what I do like about the accumulation of knowledge during my lifetime, I think all of our lifetimes, is that we have solved a lot of mysteries. You know, we have discovered the Higgs boson, but at the same time, we also have these nasty, so to speak, not so much accidental, but nasty, unexpected discoveries of dark energy and dark matter, which constitute, as Leonard Nimoy says in one of my slides, the 95% of the universe we don't even understand. We know what it does, but we don't know yet exactly how to fit this into our knowledge of matter and energy.
Is it possible that instead of a big empty, we could have a big crunch if there's enough dark matter and dark energy?
Yes, it's those three assumptions that I pointed out are crucial. If in fact the value of repulsion of dark energy changes, then you will get a slowdown and you will get a contraction and you will get a crunch. Although I didn't look into it too deeply, if in fact at some very distant time protons actually decay, then you would basically get the entire universe just turning into dust and falling back on itself as well. So yeah, it could certainly happen.
That means the boundaries of the universe shrink back to the original point?
Well, yeah, I think so, because Einstein's theory of space and time suggests, of course, that mass has a great influence on the shape of time. And so if everything shrinks down, yeah, you would basically end up with a point again.
Same thing would happen if matter just disintegrates and disappears.
Right.
Then it would collapse on itself because you don't have anything to occupy the space.
Right, and so you'd have this
non-exist then.
So you would have this massive contraction and reach a point where probably it would be so hot and energetic that it would have to just repulse again. I think it's very interesting to note that, you know, the discovery of the background microwave radiation is the boundary of the visible universe. But if the rate of inflation is, as some physicists have predicted, the total universe could be 10, 100, or 200 times the size of the visible universe, which, again, just absolutely boggles the mind.
Wow.
It would be nice to somehow run the movie forward, wouldn't it? See how it all turns out. Well, if the black universe is a series of frames, maybe we can figure out how to observe the future someday.
I hope I'm around to see that.
Well, I think we all would like to see as many frames as possible.
Right.
Right.
The future ain't what it used to be.
Right. Well put.
Have you ever seen the theory that the universe is expanding locally, meaning as far as we can see out, but not expanding beyond that point because we don't know what's beyond there? So it could be on a return trip for all we know.
Oh, you mean that the stars in the visible universe are expanding, but not in the universe beyond it?
Right.
Right. Yeah.
I've seen some of those, and that boggles my mind.
Yeah. You know, I remember very vividly. I went to the I think it was the Field Planetarium in Chicago. Did I get that right? Because the Adler's in New York. Yeah. So I went to the Field on a business trip several years ago, and I had some free time, and I went in and I saw a presentation, and the scientist who made the presentation talked about the Big Bang and the expansion of the universe and the existence of a boundary for the visible universe. And I remember when the presentation was all over, I had no idea at that point just, you know, how much of the universe was beyond the boundary of the visible universe. And I thought, here's a man who will probably be able to enlighten me. So I walked up to him at the end and I asked him the question, how much larger is the total universe compared to the visible universe? And he went into like a fit. I mean, he just literally was vibrating and he was stumbling over his words and he was saying, we don't know. We don't know. It could be 50 times. It could be 5. It's a mystery. I don't know if we'll find out. It's just like, you know, I had somehow pricked a sensitive spot in him. And it made me after that think, geez, maybe this really is, you know, a great and worthy, as Michael says, stick to poke, to see if there's any way that ultimately we can figure out just what was the rate of inflation. What do you think, Michael?
Yep, your sound is off, Mike.
We still can't hear you.
Michael, turn your phone on.
Turn your volume. Mike.
There you go.
Okay, so Michael, is that a stick worth poking, trying to come up with some type of means of determining just how much bigger the total universe is than the visible universe?
Actually, that's known, isn't it? You can extrapolate, can't you?
No, because what's beyond the observable universe is by definition not observable. So there's no way that you
can. We have a rate of inflation and we have age of the universe.
But do we really have the rate of inflation? Because if we have that, you're right.
Okay, well, that's an if. I don't know. But if we do, then that's knowable.
Right. Isn't inflation over?
Well, inflation with a big I. Yeah, that happened for a little while, right at the bang.
That was Alan Guth's research at MIT. He said that the entire universe went from the size of a subatomic particle to the size of, you know, a grapefruit, you know, in a fraction of a second. But after that, inflation was reportedly over.
Well, I read that it was the size of the solar system where it stopped. But it doesn't matter. It's done. Yeah, that inflation with a big I isn't what I was talking about. I was talking about expansion. Sorry.
All our expansion theories that they seem to have, though, seem to limit us to the speed of light. If that isn't the limit,
no, inflation was faster than the speed of light.
Right.
Huh?
Right. It was many, many times faster than the speed of light. But also realize that in the very beginning, there really was no matter. There was this super hot energy. So mass wasn't an issue until it began to cool and coalesce. I also like the notion that the universe, you know, we think of the Big Bang as being this big, violent, you know, glowing explosion, which it wasn't, because there was no photons to carry the visual information, even if you were around to see it. Took a long time before photons shook free.
And that's the uncoupling, right?
Yeah. Of something like, I think, 250,000 years it's been calculated.
Yeah.
Another mind-boggling question would be, how many photons are there in the universe?
As many as there need to be.
Yeah, good point. Good answer.
So if we found the photon, when are we going to find the graviton?
Another good question to shake the stick at.
Well, we have gravity waves, and gravity waves have to be composed of gravitons, just like any other type of light or, you know, electromagnetic radiation is composed of photons.
Yeah. So what is the technique to need it to discover a graviton?
something a lot bigger than the biggest hadron collider that we have now, probably. I don't know.
Yeah.
What do you think?
They're building a new one.
I really want a graviton. I want to get a T-shirt when they come up, when they find it. You know, they found the gravity wave. They should find the graviton.
Why don't you make a T-shirt that says they've already found it and see what happens?
Yeah, something.
No.
Hey, man.
All right, yeah, why not? Maybe, yeah.
Go get a graviton. Go find me a graviton.
Be the change you seek.
I mean, they got to be somewhere. They're in the comic books all the time.
Of course. Isn't it remarkable how much of science fiction from years past have actually come true?
Yeah.
Yeah.
So theoretically, the block universe, that gravitons already exists, just not in our frame. So
Right. The knowledge of the graviton is out there. All knowledge is, stacked up on the frame somewhere along the timeline.
We just have to get there.
Yep. Well, I thank everybody for your
Thank
input.
you very, very much. This was
Yeah.
great.
it's
Yeah.
excellent.
Thank
Then we
you
got
very
our
much.
heads
This was fascinating.
thinking.
Yeah. Well, it was a lot of fun to present it here tonight. Thank you guys for all, your input and for attending.
Oh, thank you very much for sharing.
My
Yeah.
pleasure.
It
This
feels
was a
great to
blast.
Yeah.
Or a big bang, whichever.
All right.
I'm gonna turn out the lights, I guess, folks.
All right, I'm
All
leaving.
right, thanks,
I'm leaving.
everybody.
Bye, everybody.
Thank you.
All right.
Bye.
Take
Bye.
care.
Thank you, guys. Take care.
Bye. Thank you.
All right, remember, everybody keep looking for Mars, please, okay? I want some observing reports, please, at the next meeting.
And make sure you post there when the January meeting is actually going to
Yeah,
be.
I'm gonna send Phil Harrington an email tomorrow, and I'm gonna ask him if he would rather do the 2nd or the 9th.
That's if you can do Saturdays. If you can't, then.
Can we do a Thursday if he can't
What
do a
about the day
Saturday?
before the GAC meeting, the 7th?
All right, so either the 2nd, the 7th, or the 9th, but
Yeah.
not the 8th. Is
How about that? That would
that
work.
okay with everybody?
That way we're covered for the weekdays and the weekend, whichever comes.
All right, so either the 2nd, which is a Saturday, the 7th, which is Thursday, or the 9th, which is
The
another
Saturday.
Saturday.
Yep.
We good with that, everybody?
I would be.
All right,
so.
all right. Hobbit, are you still on? I sent you the email of all the speakers that we have so far. John?
I think he's done.
John is gone?
Yeah, John's gone.
Gone is John? Gonzo is Johnzo. Okay,
That's his bedtime.
all right. Yeah, I gotta go to bed too. Good night, everybody.
All right, good night, guys. Here go the lights.
All right, another
Bye.
successful meeting. Signing off.
See you
Bye.
next month.